So now let's say that we're given this function here. We're given g at x is equal to x times the secant x squared times tan x squared. And we're asked to find the integral of that. Okay, so we're asked to find the integral. Okay, find the integral of g at x dx. So how do we do this? Okay, this one is a very, very complicated looking one. Well, it turns out it's actually not. Okay, if you realize this. If you realize this bit right here, okay, this secant x squared tan x squared portion, that is actually the derivative of a secant function. Okay, it's the derivative of a secant function. So what that means is that the integral of this must be a secant function. Okay, if this is the derivative of a secant, or so if this is the derivative of a secant function, then the integral of this must be a secant function. So the way we can look at it is this. So this here. So the integral of secant of something times the tan of that same something, okay, times the derivative of that something with respect to x dx is equal to the secant of that something plus our constant c. Okay, so now all we have to do is we have to get this, put this integral in a form that looks like this here. Okay, and once it's in this form, we can go ahead and convert it to secant. So let's go ahead and do that. First, let's define our placeholders. So we know that this box here, okay, is equal to x squared, and the derivative of that box with respect to x is equal to 2x. Now that our placeholders are defined, we can go ahead and start working this integral. So the integral of x times secant of x squared times tan of x squared dx. Okay, we can also write that in by substituting in our placeholders. So that would give us x times the secant of this box here times the tan of this box dx. Now, as you can see here, we have a slight problem because it's in a dx form. What we want is to be integrating with respect to this placeholder now. So to do that, to make that conversion, we just simply multiply this expression by the derivative of that placeholder. Okay, so by d box by dx. So we would get this expression, x times secant times tan box, okay, times this, okay, so our d box by dx. So as you can visualize it here again, you think of these dx's canceling out. So when we put the numbers back in, we get this. We get the integral of x times the secant of x squared times the tan of x squared times d box by dx, which is 2x. Okay, now keep in mind here, we already have an x here. Okay, we already have this x here. So to make sure we have 2x, all we have to do is multiply this by 2. Okay, we don't have to make another 2x because that would change the entire thing. So we just multiply this by 2, and now we have our 2x, as you can see here. Okay, dx. Alrighty. So now this is in a good form for integration. So now what this looks like is this. I'll just rewrite this here. So write this here. Secant of x squared times tan of x squared times 2x dx. So as you can see here, this entire integrand here is in this form here. The only problem with it though is that this is a slightly different looking function than our original here. Okay, it's a slightly different looking expression because of this 2. Right, this 2 changes everything. So to make this entire expression still equal this expression, all we have to do is just cancel out the 2 somehow. And the way we do that is by multiplying by 1 over 2. And we'll put it outside the integrand here so that the integrand still takes this form here. So now the integrand is in the proper form, like so, for integration, and the entire expression is in the same form as, or sorry, is still equal to the original expression. So now we can go ahead and make that conversion to secant of our box plus c. So when we make that integration, we get this. We get secant, or so we get 1 over 2, okay, 1 over 2 times the secant of our box, okay, which is x squared plus c. And this is our answer. And just another quick trick to remember too, I'm just going to scroll down here and show you something else. If you're ever given a function that has this form here, so if you ever see something that looks like this, that has cosecant of something times cotangent of something, just remember that this is actually the derivative of a negative cosecant, negative cosecant of something. Okay, so that means this, okay, the integral of this will be cosecant of that. Okay, and then similarly, if you ever have something that is a cosecant squared, okay, cosecant squared, if you ever asked to find the integral of a cosecant squared, just remember that cosecant squared is the derivative of a negative cotangent. Okay, so that means if you were to take the integral of a cosecant squared something, it would give you the cotangent of that something, as long as you're using the same, as long as it's in this form here.